Free response question number 5, part B. Find d squared w dt squared in terms of w. Use d squared w dt squared to determine whether your answer in part A is an underestimate or an overestimate of the amount of solid waste that the landfill contains at time t equals 1/4. So first of all, we take dw dt, which we were given. Dw dt is 1/25 times w minus 300. And we take its derivative with respect to t. So we get d squared w dt squared equals. All right, what is the derivative of 1/25 times w minus 300? Now, really this is 1/25 w minus 300 over 25. And so the derivative of this is, well, 1/25, but it's important that you remember times the derivative of w, which is dw dt. So that means 1/25 times the original dw dt. So 1/25 times 1/25 w minus 300 is your second derivative. Notice it says find d squared w dt squared in terms of w. So you have to have a w in it. So this would be your second derivative. Now, the second part says use this d squared w dt squared to determine whether your answer in part A is an underestimate or an overestimate. So what we want to do is we want to determine whether this equation tells us that the graph is concave up or concave down. So if I consider w, of course w is 1400 at t equals 0, so w is increasing because the derivative is positive. And so now we want to think about whether or not w is concave up or concave down. So you know that because w is going to be greater than 1400, you know that d squared w dt squared is going to be greater than 0, or in other words, concave up. So w is a function that is increasing and concave up. So in part A, we used a tangent line to approximate the value of w. So you notice that the tangent line is always underneath a concave up function. Therefore, our estimate is an underestimate. So you can write part A's estimate is an underestimate because d squared w dt squared is greater than 0. Therefore, a tangent line approximation will be an underestimate.